The Argand plane is a geometric way of representing complex numbers. Each complex number corresponds to one unique point on this plane. The real part of the complex number is plotted on the x-axis, while the imaginary part is plotted on the y-axis. So, a complex number z equals a plus iota b is represented as the point P with coordinates a, b in the xy plane. This representation helps us visualize and work with complex numbers using simple geometry. The point P with coordinates a, b stands for the complex number z equals a plus iota b. The distance from the origin, that is 0, 0, to this point is called the modulus of the complex number, written as modulus z. The direction of the line, or vector, from the origin to point P gives us the argument, or angle, of the complex number. So the modulus and the argument together completely determine the position of a complex number in the Argand plane. For example, if z equals to plus 4 iota, the point is to 4, the modulus is square root of 2 squared plus 4 squared, which is square root of 20, and the angle is found from the slope of the line. A complex number z equals a plus iota b can also be written in what is called polar form. In polar form, z equals r times open bracket cosine theta plus iota sine theta close bracket. Here, r is the modulus, which is modulus z, and theta is the argument or angle of the complex number. This form is very helpful, especially for multiplication and division of complex numbers. The angle theta is always measured counterclockwise from the positive x-axis. For example, for z equals to plus 4 iota, the modulus r equals square root of 20 and theta equals tan inverse of 4 divided by 2. We can move between rectangular form and polar form. To convert from rectangular form a plus iota b to polar form, calculate r equals square root of a squared plus b squared and theta equals tan inverse of b divided by a. To convert back from polar form, we use the formulas a equals r cosine theta and b equals r sine theta. These conversions are very useful for carrying out operations like multiplication, division, and raising complex numbers to powers. For example, if z equals to plus 4 iota, then r equals square root of 20, theta equals tan inverse of 4 divided by 2, and the polar form becomes square root of 20 times open bracket cosine theta plus iota sine theta close bracket. Let's work through an example. Consider the complex number z equals 1 plus iota times the square root of 3. The modulus r equals the square root of 1 squared plus the square root of 3 squared, which is 2. The argument theta equals the inverse tangent of the square root of 3 divided by 1, which is pi over 3. Therefore, the polar form of z is 2 times open bracket cosine pi over 3 plus iota sine pi over 3 close bracket. This representation makes it much easier to perform multiplication, division, and other algebraic operations with complex numbers. Let's recap what we learned. The Argand plane is a geometric representation where the real part of a complex number lies along the x-axis and the imaginary part lies along the y-axis. The modulus is the distance from the origin, while the argument is the angle from the positive x-axis. The polar form of a complex number is written as r times open bracket cosine theta plus iota sine theta close bracket. We can easily convert between rectangular form and polar form, and this is especially useful for multiplication, division, and exponentiation of complex numbers. Polar representation is one of the most powerful tools in the study of complex numbers.